Hi, this is Tag again, and today I'm going to do version 2 of my ASUS A7N8X modding guide. Because since the last one I did, the last video, I did a bunch of socket A benching and discovered some minor tweaks and like minor failures from my side I did with the last modding guide, as well as I discovered, or rather found out or learned the importance of a whole new mod. So I'm going to include that as well. So let's get started with Vcore. Now Vcore on these ASUS boards usually is derived from the 5V rail, and the first thing you want to do if you want to bench those is switch the input voltage to the 12V rail. Now what you want to do for this is basically, this is the input filtering choke. You want to desolder the bottom leg, so there you can see the pad here, I think. Lift it up, bend the choke sideways so it's out of the way. I find it really convenient to put it sideways directly above these two fan headers here. And then you want to solder something like a 4-pin or an 8-pin EPS to it. Now, personally I use the 8-pin because of increased physical stability. I had a 4-pin on my benching board before, and well, I dropped the power supply off the table and it ripped off the 4-pin because it was only attached like on two of those flimsy bent over sheet metal pins that are in this connector. So I switched it to an 8-pin and now it should be safe. Next thing you want to do is, after you have attached the bent up leg of the choke to the top 4 pins of this 8-pin, you want to attach 2 cables here and sort of lead them around to these power planes that are the ground power planes for your low side FETs. Now on this board I used, this is just 1.5mm, I think, or is it 2.5, I don't know, single strand wire, and I used the brown one so it matches the board. It's just aesthetics, but I wanted to make this look nicer than my benching board does, as you can see. Now input filtering here, I would recommend going with something like 560 to 1500 microfarad aluminum polymers. The 1500s I have on here are not necessary, but those are Chemet A750s and they are pretty low ESR and pretty cheap. That's why I use them. On my benching board, this is a completely inadequate, well, not inadequate, but like not proper solution. Those are 330 microfarad Nippon Chemicon PS series from 2005 or 2006. 2006 according to date code. So don't do this, use some proper ones. But back in the time I was waiting on my Mauser order and I still haven't gotten around to replacing them with the proper ones. So that is your 12V mod. Let's move on to my benching board, because this one doesn't have a volt mod yet. And also output filtering. Now output filtering here is, those are 1500 microfarad. Again, salvage PS series, not the right way to do it. I would recommend using something like the Chemet A750 series again. There is a 2200 microfarad 4V rated version with those 5mm lead spacing. I think this is 10mm diameter package. Those are really cheap and they're also either 7 or 8 milliohm ESR, so really good ESR as well. And I would recommend using those for here. So 2200 microfarad Chemet. The actual Vcore mod is unfortunately hidden by my installation, my art eraser here. So can't show you that here, but I'm going to obviously show you it in the detailed mod overview section on the computer later. Just basic feedback mode and a selectable jumper for disabling your mod. Next thing in the socket area is this little switch up here. This sets your 5th bit of your frequency identifier, so your multiplier, because the ASUS board doesn't have all of them wired up, so you need to set one of them in hardware so that you can use multipliers above 12.5 if your CPU has a stock multiplier below, and vice versa. So if this switch is on off, it is running below 12.5, and if it's on here, it's above 12.5. Now this is done by one little pin here. I'm going to do obviously a detailed overview of that one as well. And what we're doing with the switch is basically switching it between Vcore for high and a ground connect for low, and that's it. Also on the CPU we have a couple of SP caps here. Now I'm going to do an overview on the computer which ones of those power planes here are ground and which ones are Vcore, so you can sort of mark out your own power planes and which ones to remove the solder mask on to put on either SP caps, so SMD polymers, or MLCCs. I would definitely recommend putting something behind the socket if you're doing extreme overclocking on this, because it does help a couple megahertz for sure. Also measurement points, I just used this yellow wire here. This is our Vcore measurement point, just goes to one of these 5 aluminum polymer capacitors. Simple as that, any of those are Vcore, obviously. Okay, let's move on to Northbridge Voltage. Northbridge Voltage is made by this little IC here, and this choke, this is basically your Northbridge Vmem. And what I found really important here is that you use capacitors with really low ESR, because Northbridges tend to scale a lot with lower ripples. So what I did here is use a bit taller ones than my usual FP caps. Those are 6.3 volt 820 microfarad, but the 8mm high ones have an ESR of 8 milliohms. Those are 10mm high ones, they have an ESR of 7 milliohms and are 1000 microfarads as well. So I use those are a bit more expensive. You can obviously also use these, probably not a huge difference, especially if you are going to do what I did here and add some MLCCs behind the capacitors here and here. Those are 100 microfarad MLCCs, 1206 package. And as you can see here as well, this is your measurement wire going to my usual model connector. Now you can use either the right pin on this upper capacitor or the bottom pin on this lower one. Actual volt mode is a feedback mode as usual, done by this here variable resistor, but I'm going to do this in detail later anyways. So that's it for your Northbridge voltage section. Now let's move on to memory. And that's where most of the changes from last video came from. My memory voltage section here is recapped since the last video, because I was running 560 microfarad aluminum polymers here, and when I tested ripple on the memory I got about 80 millivolts when running SuperPi 32M, which is not good at all. So I realized that I needed to up capacitance, because the ESR was also good on the previous capacitors, so I changed the input filtering for 820 microfarads, the output filtering for 1000 directly after the choke, and 820 on the far side here. with just these changes, I got to around 40 millivolts in Super32M. The voltages I was running were 3 volts for the memory. So I wanted a compromise between high voltage to basically stress the VRM, but not high enough voltage that the memory gets too hot. Because when I do oscilloscope testing, the board is upside down on my bench and I can't put the fan on the memory. So the maximum I wanted to give my good Win1 sticks was 3 volts without cooling. So that's the reason for the 3 volts. Anyways, I got to 40 millivolts ripple with just the aluminum polymers, and then I also added some MLCCs, 1, 2, 3 and 4 on the back, and with that I got to around 20 to 25 millivolts ripple. So the significantly decreased ESR really helped from the MLCCs. Measurement points would be the bottom one of this capacitor, this red wire is my Vmem, bottom one of this capacitor, and on both of those it would be your right pin. That would be also Vmem. Now the Vmem mod itself is this variable resistor here, it's just a feedback mod. Really simple thing. Detail later, obviously. So next thing that I completely missed in the last video is the VTT here. Now this little variable resistor here is my VTT mod. Why do you want a VTT mod on here? Well, it's actually sort of the opposite of a regular volt mod, because you want to lower the VTT. You're going to lose stability over a certain voltage when you run VTT at exactly 1/2 memory voltage. It's sort of like DDR4 B-die, where you also have to, in some situations, fix the VTT at a voltage that is lower than 1/2 of memory voltage. So that's basically what we do here, but we can also raise our VTT. Because the mod is connected to this here, this is a dual op amp in a single package, and we just connected it to the non-inverting input of the op amp that's for your VTT control, so controlling this FET essentially. And then I connected one side to ground. There is a small capacitor here, just directly to save wires again. And the other side is connected to a rail directly derived from your memory board. That is a bit odd about this board, and I'm still not sure if it's a good thing or a bad thing. Basically, what ASUS did is put the voltage divider for your feedback here on this VTT, not between ground and Vmem, but between ground and basically a voltage switched through by this little here, this tiny one here, from Vmem. So it goes across the board. I don't know what the point is, and I expect it to be probably better if you would switch it directly to Vmem, because it could react quicker. I haven't yet tried that, but I did a bunch of testing here and I had absolutely no problems with like voltage stability under load. I didn't have any significant drop when I started tests that would go well beyond ripple, just a 10-20 millivolt drop. So I didn't have any issues with it being slow, at least not any issues I could see with my oscilloscope. I don't have a fancy digital oscilloscope, which is kind of unfortunate, because with that you could definitely check if this thing reacts too slow or not. Anyways, That's your VTT mod. Details later, obviously. And I also recapped VTT. I replaced the electrolytic here and here with polymers. Those are 820 microfarads, 2.5 volts. Those are still salvaged ones, but they seem to work fine. I also populated the unpopulated pad down here with another 820 microfarad, 2.5 volt. Those are Nippon Chemicon PSE series, salvaged from, I don't even know, I think a Dell or a HP motherboard. But at least they are not as old as the ones I'm running on Vcore, so I guess that's a positive. If I was going to go with new caps, I would go with something like a 560 microfarad 6.3 volt FP series in the same package. Would be probably the best choice. Yeah, I think that's about it. Actually, no, I didn't show you VTT measuring points. Obviously those 3 caps, and that's just what I did. I grabbed the right leg of this one, and I think they're all oriented in that way, yes. So right leg of any of these 3 caps would be your VTT measurement point. So yeah, that's it for the mod overview on the board. At least the hard mod overview. There's also modded BIOSes, and I'm going to leave a link in the description to a folder with a bunch of modded BIOSes by a German guy named DigitalBath. He makes amazing mod BIOSes, and from the ones in the folder I'm going to attach, my personal favorites are the v2.0 revisions. They're basically the latest ones he made, and have a bunch of features unlocked and also moved around. So all the overclocking features are in one submenu, not strewn all over the place like ASUS did back in the day. They also have ROM zip selectable from BIOS, so you basically have almost everything in one BIOS and don't need to like flash flash different mod BIOSes for different things. You can just use the one BIOS and basically going to be mostly good with it. Anyways, those are my personal favorite. There's obviously other ones as well, but yeah, I think that's it for the hardware mods. I'm going to now move on to the detailed volt mods and the FID mod on the computer. See you there.
Okay, here we are. So let's start off with Vcore. You want to count 1, 2, 3, 4, 5, 6 pins up. And here you have your feedback pin. You can also grab it from the bottom of this capacitor or the bottom of this resistor. That both works fine. Now from there, what you want to do is your typical variable resistor. To ground. And for ground points, if you have to use ones that are in the area, it would be the bottom pad of this capacitor or the left pad of this one. Now, personally, I would recommend using ground pads or using the case ground of one of your I/O ports and directly soldering to that if you put the variable resistor on top of the I/O like I did. Value-wise, I would go with something like 20 to 50 kilo ohms here. Personally, on mine, it's a 20. But with a 50, you have a bit lower minimum voltage, obviously. So 50 would be the choice if you're not on extreme cooling and you don't, well, not in extreme cooling and you don't want to bother with a jumper like I did. If you are going to run a disabled jumper, I would prefer 20 kilo ohm over a 50. So that is your Vcore mod. Let's move on to our Northbridge Voltage. Okay, here we are. So it is also a feedback mod. Now on this one, it is 3 pins up from here, and you can also grab it on this and this here, so this resistor and this capacitor. Now what you want to do here is run a variable resistor again to ground. There is also a alternative version. Yeah. Now the alternative version would be to run a resistor in series with a variable resistor. There is a good reason for that, and I'm going to explain that shortly. So this and then the ground here. Now, if you're just going to go with a variable resistor, you would want a 2 mega ohm variable resistor here. And it's not like super easy to find one of those. Much more common, you're going to have 1 mega ohm. So what I personally prefer doing is do a 500 kilo ohm rather, fixed resistor in series with a 1 mega ohm variable one. Those are much more common values, so should be easier to find. Grounds in the area would be this unpopulated pad is probably the easiest ground to grab, or the left pads of these two capacitors. But again, I prefer using the shielding of my I/O ports as ground. So yeah, that's it for the I should put a red here. So this is either this upper solution or this lower solution. This is it now for the VDD or V Northbridge mod. So I'm now going to move on to Vmem and VTT. Okay, here we are with our Vmem area. Now let's start off with Vmem. You want to go 1, 2, this is your feedback pin of the memory. And you can also grab it at this unpopulated pad or this large capacitor here. Now from there you want to do your typical variable resistor. And this to ground. There we are. Now value wise you would want something like 20k to 50k again. Personally I use 20, but 50 is also fine. You're just going to lose a bit of fine adjustment range at high voltages. Now, if you're just going to run win bonds on here, I might even recommend using a 10k. But then your minimum voltage is going to be really high. So this is win bond only. Win bond gives you a bit more fine regulation, like above 3.6 volts or above 3.4. So that is your Vmem. Now let's move on to VTT. Now the non-inverting input would be this one. So this is basically the pin you want to solder the middle pin of your variable resistor to. So let's draw a variable resistor. And you want the middle pin connected to this here. And then you want the outer two pins, one connected to your 2.5 volt, which would be here. So the bottom pad of this capacitor or the top pad of this resistor. This would be one side of your variable resistor. And the other side you want to connect to ground again. So this would be your VDT control circuitry. Now values here go with something like 10 to 100 kilo ohms. 100 kilo ohms. Personally, I use the 20 kilo ohm again because 20 kilo ohm for everything is basically your voltmetering standard anyways. So yeah, that's basically your VTT control circuitry. let's move on to our frequency mod or multiplier mod, and I'm also going to show you the back of the socket for some pads for soldering capacitors onto. Okay, here we are. So this is the back of our socket. And as you can see, I actually painted the pads on the board so you can see it. Now, red is Vcore and black is ground here. So what I use for mine is these middle pads here. So the middle one is ground and these two are Vcore. The only thing you have to be really careful with this is to not basically short these wires with the circle around them to anything else, because those are not the same net as the surrounding power plane. Shorting across these barely visible wires here, the small ones, is perfectly fine. So scratching off, for example, a large chunk right here, like something like this, would be perfectly fine. Now for our multiplier mod, you want to grab your FID bit 5. I think that's this one, yes. So that is your pin. And this unpopulated header up here, the square pad here, is a good source for your Vcore. So actually, let's make this red. So this is red, this is Vcore. Vcore. And what you basically want to do is go out from here. And draw it like this, I guess. Basically a switch to here and highly professional switch and a switch to ground on this side. So you can switch it between ground and Vcore. Now obviously just using a jumper and like soldering this pin to the middle leg and one of them to the Vcore here and one side to ground would be the easiest solution. So one of the outer pins each. So yeah, I think that's about it for the mod overview on this board. I hope I didn't miss something again, but yeah, with all the stuff that is in this video, you can definitely make the board very, very overclocking capable. So even if I missed something, you're still competing very well with just the stuff I put in this video. Anyways, that's it. Bye.